Let's solve this exercise. Write down the equation of the straight line which is perpendicular to R and which passes through the point B. This is the line in the general equation form, and this is my point. Let's say that this is the line. So we are looking for another line that passes through the point B. Let's say that the point is here and is perpendicular to this line. So we are looking for a line like this. When I look at the general equation form, I obtain certain information, and the information is that a normal vector to the line R equals this. Normal vector means, this is line R, remember, that is perpendicular to line R. But since we need a line that is perpendicular to this line, this vector could be a directional vector for the line I'm looking for. So quite easy. The general form, for example, the vector equation of the line we are looking for could be for -1, which is my point, plus lambda, and now the coordinates of the vector. That in my case would be this. And the exercise is over. This is the equation of the line. But let's say that we want to have all the forms of the equation. So I'm going to go on looking for all the forms of the equation. First one would be the parametric form. The parametric equations, we obtain them operating here. So xy would be, I put this point, and then I need to multiply this by the vector. To multiply a vector by a number, we just multiply every coordinate. So in this case, it would be like this. And to add vectors, we just add the coordinates. So it would be 4 plus 3 lambda for coordinate x, and -1, I forgot lambda here, minus 2 lambda in this case. So my parametric form would be x equals, if these two vectors are the same, the x coordinate must be the same and the y coordinate as well. Plus 3 lambda, and y must be -1 minus 2 lambda. So these are parametric equations. This is the vector equation. All right, so the next equation will be the 2-point form. To obtain the 2-point form, what I'm going to do is isolate lambda here and here and equalize. So in this case, it would be this 4 goes to the other side subtracting, so x minus 4, and once I have the 4 here, this would go to the other side dividing over 3. This equals lambda. And I'm going to equalize it to what I obtain isolating lambda in the second equation. It would be y plus 1 over, and this would be dividing. So this is the 2-point form. Now, to obtain the other forms, we are going to multiply like an x, because we can do that when we have an equation. And remember that this -2 multiplies everything here. Don't forget, a bracket is compulsory. And 3y plus 1. So this is -2x plus 8 equals 3y plus 3. Let's say we want to have the point slope form. What we have to do is we need to calculate first, in this case, the general form of the equation. So let's organize this. We would have -2 minus 3y. This comes to the other side, subtracting as well, plus 5 equals 0. This would be my general form. Or if we don't want to have so many negative signs, we can change the whole equation, the whole equation's sign, like this. This is the general form. Then we need two more. First, the slope intercept form. Let's isolate y. To isolate y, I leave it here. I place this here adding, and this one subtracting. And now I have to divide by 3 the whole equation. And I would have, let's change the order at the same time, negative 2/3 x plus 5 over 3. This would be the the slope intercept form, sorry. The slope intercept form. And the last thing that I could do would be the point slope form. Point slope form. And to do that, I'm going to use this step. When I multiply it like an x, I obtain this. So I'm going to isolate this. Look, y minus plus 1 equals. Then this will move to this side dividing. And I have this. And here you have all the equations that we can write about a line, at least this year. So let's analyze these equations a little bit. Vector equation, this is the first step we did and you know how to do it. Then parametric, look here, you can recognize the point that my line passes through, which is 4 and negative 1. And here you can recognize the vector, the directional vector, which is here. In this case, here I have the coordinates of the point, but with the opposite sign. You can check it. And here, in the denominators, you have the vector of the line. In the general form, remember that these are the coordinates of a normal vector. The normal vector for my line, not for my line R, for the line I'm looking for would be 2, 3. And in fact, if I do scalar product of this vector and this vector, the result is 0. So that means that they are perpendicular. The slope intercept. Remember that this is the slope of my line and this is the y-intercept. This is where my line intersects y-axis. And here in the point slope form, here I have the coordinates of the point where that the line passes through. With y is the y coordinate of the point but with opposite sign. And with x is the x coordinate of the point but with opposite sign. And here we have the slope of the line as well. I hope you understood. See you soon.